All right, let's take a journey into something you see in the mirror every single day but probably don't really think about. I'm talking about the incredible armor that protects your teeth. We're going to unlock the secrets of your very own personal crystal fortress.
So, let's start with a simple question. We all know our bones are tough, right? But what's even tougher? What is the absolute, hands-down, hardest substance your body can make? Any ideas?
If you were thinking tooth enamel, you are exactly right. It is the most mineralized and therefore hardest tissue in our entire body. But look closely at that description. Non-living and irreplaceable. And that, right there, is the fascinating paradox we're going to get into.
Yeah, this is what I call the enamel paradox. On one hand, it is an absolute marvel of engineering. I mean, it's a shield that's built to take a pounding, day in and day out from all the chewing we do. But on the other hand, because the cells that build it are gone by the time the tooth comes in, it has absolutely no way to repair itself. None. Once it's damaged for good.
So what's the secret sauce? What's the recipe that gives enamel this kind of superhero strength? How can it possibly be harder than our bones? Well, it all comes down to what it's made of. Okay, check this out. The numbers are just wild. A full 96% of your enamel is just inorganic minerals. We're talking mostly a super hard crystal called hydroxyapatite. Only a tiny 4% is organic stuff in water. This incredible density of minerals, that's the secret to its insane hardness.
But here's the thing. Pure hardness isn't the whole story. If enamel were just one solid block of crystal, it would actually be super brittle, like glass. It would shatter. That's where that little 4% comes in. That tiny organic mesh works like a flexible scaffold, like a shock absorber, giving enamel just enough give so it doesn't crack under pressure. It's the combination of the two that makes it so effective.
Okay, now let's zoom in. Way in. Because the real genius of enamel isn't just what it's made of, it's how it's built. The architecture is just mind-blowing.
Get a load of this number. A single upper molar, one of your big chewing teeth in the back, has up to 12 million of these little structural pillars called enamel rods. 12 million. That's how densely packed this stuff is.
And these rods don't just stand there in straight lines. Oh no, they take this wavy, curving path from the inside of the tooth out to the surface. And in the spots that take the most stress, like the pointy tips of your teeth, they get all twisted and braided together. They actually call it gnarled enamel, and it's what provides maximum strength right where you need it most. Just brilliant design.
But we can go even deeper. The real secret to enamel's amazing resistance to cracks isn't just the wavy rods. It's the structure inside the rods themselves. This is where things get really cool.
To even understand this, scientists have to get pretty creative. And one of the wildest things they found is that if you take a tooth and use an acid to dissolve all those hard minerals, the enamel structure just vanishes. Poof. It completely disappears. It's a pretty dramatic way to show you just how little of that organic scaffolding is actually in there.
And if we look at a cross-section of these rods, we find they're shaped kind of like a keyhole. You've got the main rod itself, the prism, which is super calcified, and it's cemented to its neighbors with more highly calcified material. But right between them is this thin layer, the prism sheath, and it's less calcified. That subtle difference, that boundary, is the whole key.
So here it is, the ultimate secret. Inside each and every one of those millions of rods, the tiny little crystals are arranged in a very specific pattern. In the middle of the rod, they run straight, but as you get to the edge, they flare outwards. This change in direction creates this tightly woven interlocking structure. It's basically microscopic rebar. It means if a tiny crack starts, it can't spread, it gets stopped dead in its tracks. It's an incredible anti-fracture system.
Okay, let's zoom back out. We've gone from the chemistry to the architecture, from millions of rods all the way down to the direction of individual crystals. So what's the big takeaway here? What does this all mean for us?
This quote from the source material really says it all. Acellular, inert, non-vital. It's a masterpiece of natural engineering for sure, but it is not living tissue. Unlike a bone that can heal, enamel can't. Every single bit of damage, whether it's from wear and tear, acid from foods, or decay, it's permanent. Once that fortress wall is breached, your body can't rebuild it.
So we're left with this one crucial idea. If you have a fortress that is unbelievably strong, but at the same time completely irreplaceable, what's your only option? You have to protect it, you have to maintain it. And that really changes how you think about something as simple as brushing your teeth, doesn't it? Thanks for tuning in.